Hello guys and welcome to this video. So in this video I'm just going to analyze an AWR report of Oracle database, and going forward I'll be using multiple AWR reports. I'll be putting a series of AWR videos. So hope you will be having a useful session. And if you want more real-time or real-world customer-facing production issues and diagnosis of all the AWR reports, then you may need to enroll for the performance tuning course, because I cannot expose everything in generic platform, right? So this is just a test system where I just generated an AWR report where the issue happened. Okay, so if you just just hit a like before you watch this video, and also for more useful videos like this in future, just subscribe and support, so that it will motivate me to put more useful information that you may not be knowing. Okay, so for beginners who don't know about AWR report, this session will be useful. Okay, so often as a beginner, everyone learn how to generate an AWR report. Okay, so that's not the actual goal of the AWR report. Okay, so the main goal of AWR report generation is to analyze the historical issue. So you always have the question, what is AWR report? So since this is the first AWR session that I'm putting in YouTube, so that's why I'm just explaining this. Okay, so why we are generating AWR report and when to generate AWR report. So these questions you should ask before. Okay, so just because if you enroll for any course, or anyone who teach you about AWR report, so they just simply say that they just simply tell you to generate an AWR report, and they will just explain everything. But before that, you may need to ask all these questions. So what is an AWR report? So AWR report is kind of a snapshot. Okay, so assume that this is a camera. Okay, so you are just taking a snap of every events that are occurring. So you are going for a wedding ceremony or any function, or you are going for some trekking, or for some wonderful place. So you'll be taking your photo, right? Your pics, your videos. So you'll be taking all the videos and events, the pictures of your events for memories, right? So similarly, in Oracle database, you can compare the same example as the AWR report for this snapshot, the camera. Okay, so how you in real life you are taking each and every incidents using the camera, either using a phone or your camera. So likewise, this AWR report is an automated snapshot. That's it. So here you are manually taking the snapshot. Even in Oracle database, we have options to manually collect the snapshots, but in a 365 24/7 database systems, it is not that easy or feasible to take snapshots regularly, right? So it will be having some intervals. Interval means, so like every 30 minutes or every 1 hour, the database needs to be monitored with the snapshots. So you cannot go and every 30 minutes you cannot go and collect the snapshots like that, right? So that's why it is AWR. AWR means automatic workload repository. It will automatically collect the workload information in the repository. That's the meaning of this. Okay, so in the form of snapshots. So here what you will do, once the pics are clicked, you will either see the screen, the camera screen, or you will just take a hard copy as a photo of the event for memories. So likewise, here this AWR will collect the snapshots of all the incidents that are happening, whether there is an issue or there is no issue. Okay, even if the current functioning is smooth, or if it is having some disturbances, it will just collect the snapshot no matter whatever, irrespective of whatever happen. Okay, so the main goal of AWR is to collect snapshots, so that you will just refer the picture, like how you are referring the picture for future memories. So likewise, for future diagnosis, you will be collecting all the information. That's it. So like how a doctor is collecting the diagnosis information, right? So if you are sick, then he will just use a stethoscope and thermometer, collect the temperature information, your blood count, your weight, your body fat, everything he will be collecting. So likewise, this AWR will collect all the features related to the features and metrics related to the database. So here in database, like how your weight, your blood count, here in database it will just collect the session count, it will collect the weight events, it will collect the SQL statement. So likewise it will just collect all the information. Okay, so why we need the AWR report? So this is the main question. So why we need? Because without an AWR report also we can survive. Okay, because AWR report is completely licensed, so we need tuning and diagnostic pack for generating an AWR report. So alternative will be stats pack. Okay, stats pack is least you can say least collected information, so it will not collect every details similar to an AWR, but AWR will be giving you all the bread and the jam, the cream, right, the cream with the cherry. So it will give you all the information to your mouth. Okay, so if you are using stats pack, you have to use your hands in the plate, and if you want to eat something, right, so you use your hands and then you put it in your mouth. So this is kind of spoon feeding AWR. So it will directly give you the information. What you need to do is you just need to understand the metrics, and you directly go where the issue is, and just you can give a justification. Okay, it is as simple as that. Okay, so stats pack has least information, but AWR will be having more information, or it will give you the information in a beautiful way, so that it will be easy for you to see all the metrics. So the main reason for the AWR report is to analyze a performance issue. That's it. This is the reason why we need the AWR report, right? So next comes when you need to generate AWR report. So we know that we are generating AWR report to analyze any performance issues. So when there is a performance issue, we need to generate. But what kind of performance issue? When we need to generate the AWR report, that is also important. You cannot generate AWR report for the current issues. Okay, so if I'm having some hang, or if I'm having some you can say slowness currently, so if you just see the present time, right, present, past and future, everything is same. Okay, so present means the current moment, past means the memory, the historical incident, and future means that is going to happen. Okay, so here you cannot say that the snapshots which are collected last 1 hour or last week snapshot, so these comes into past, but still the current snapshot that is collected which will come into present. Okay, so here you cannot completely say that you are the AWR report is collecting past or present information, but still when you will generate an AWR report, so when there is a persistent issue, persistent means weekly issue, so last Friday or last Monday, any day you can take, last Friday the job was running good, and this Friday it is running bad. So this is kind of a persistent issue and a system wide issue. So in AWR report, it is kind of a cumulative, it collects the cumulative information. So you can use AWR report for system wide issues. System wide means all over the database the slowness is happening. So if only one SQL statement is running slow, you cannot, still you can generate AWR report, but AWR report will not give you much information. That is the case here. Okay, so for every issue you can generate an AWR report, but when and where it is significantly useful, right, that's when you will be generating an AWR report. So you can take any real-time example. Okay, say for example, so in during hot days, right, so you will not be eating heat generating food. Okay, you need something cool, so you will be having water, or you will be having some juice, so that you will get hydrated. right? So during cold days, what you will do, you will just drink hot water. You need something hot during cold days, right? So similar to this, you can use the AWR report. Okay, but still during hot days you can also have hot food. That's individual's choice. Okay, but when and where something is required, there only you will be having something useful. So likewise, when AWR report is significantly useful, like during hot days you will be having any juice or coconut water, so that will be very useful for you during those hot days to get hydrated, right? So likewise, during system-wide issue, during persistent issue like repeating issue, right? So also during high load. So these kind of scenarios are the basic situations when you will be generating an AWR report. Okay, so you cannot generate AWR report for a limited period of issue. So that the issue time is only 2 minutes. So here you cannot generate an AWR report. Okay, so generally it's a rule of thumb that we keep the AWR interval as 30 minutes or 1 hour. Okay, because the AWR report itself is a system-wide cumulative information. So that's why either we use it as a whole or we don't use it. For 2 minutes, 1 minute issue and all, still you can generate an AWR report, but it will not be much useful for you. Okay, so let us just come into the AWR report and diagnose it. So first row is just a basic information about the DB information, then instance information, and this is the container information. Okay, so if you want to know whether it is a rack system or not, you can understand this. You don't need to ask your client or customer about the system information, right? If someone is giving you an AWR report, by seeing the AWR report itself, we can easily find out whether it is a rack system or a standalone, whether it is a CDB or non-CDB. Okay, for that reason these information are given. Okay, you don't need to ask extra information to reduce your troubleshooting time, right? Otherwise you need to contact your client and you need to understand, and he also need to understand what you are asking, right? So if the client has only the database information but he don't know what exactly Oracle is, then it will be difficult for understanding, right? So you just just have a short or a little peek on this information. Once you have the clarification, you start your diagnosis. So if it is a rack system, your diagnosis will be completely different, because a lot of global events will be there, because multiple nodes are there. So you need to ask for the other node AWR report as well, right? Instance wide AWR report. So your diagnosis path will be something different for a rack system. Okay, so that's why it is very important that first you need to see this information. So once you understand that this is not a rack system, then you go and check the capacity. So this is actually the capacity of CPU, the core sockets, then the memory capacity. Okay, so these are just informational. You don't need to waste your time on these things. Okay, and the next one is the main part. So this section contains the issue start time with the end time. Okay, so generally every AWR report should have only the issue time interval. Okay, the interval for the AWR report that you are collecting should be between the starting snap and the ending snap. So that starting snap will be the start time of the issue, and if the issue is still going on, or if the issue already ended during the historical phase, then you need to take the end time as well. Okay, so generally it is recommended to take either 30 minutes of interval or 1 hour of interval, but majority of the time it is recommended to take 30 minutes of AWR report, because if you have 1 hour of report, that will you will miss lot of details, because this will be a cumulative average statistics that will be collected, okay, related to every metrics. Okay, so that's the reason in 30-minute report you will get a lot more deeper level of information. Okay, and even if you are asking for any client or customer to generate an AWR report, you should tell the client or customer saying that you need to collect for this particular time period when the issue happened. Okay, so we cannot generally collect a random AWR report like some random time, right? Always you should focus on the issue time. And if you see, the sessions column is also very important. Okay, so this shows us how many sessions were connected, so how many people or the number of sessions were connected. So this will give us an idea of the increasing or the decreasing sessions. So here if you see, during the start time the number of sessions were 65, but during the end time it decreased. But when you see cursors per session, so cursors means the sessions will be allocating cursors before they execute any SQL query, right? So in the memory, in the shared pool, obviously every sessions which are executing SQL statements should be having some cursors which will be a pointer, right? So every individual sessions will be having a private area which will be stored in the PGA, right? And those cursors should be pointing to the shared memory, so that cursor information will be printed here. So here even though the sessions are reduced, but still the cursors are increased. Okay, so this is just an indication that the sessions were reduced. Okay, but we don't know what exactly. So one session might have consumed more, you can say one session might have executed many jobs, or individual sessions might have executed individual jobs. So there are lot of ratio based probability of these are just assumptions. Okay, so we cannot exactly say if we have an increase of cursors, that means there is an issue or not. This is just an indication. So you just need to, you can take any notepad or whatever favorite notes, sticky notes, or even you can write it in a notebook, right? So during the start time 65 sessions were there, during the end time it got decreased, right? 9 sessions decreased. Just for your understanding, you can just write it something like in a notepad, and each session allocated 2 cursors, and between the start time and the end time. So during the end time only 54 sessions were there, right? So 54 sessions. So each session opened almost 2.2 cursors. Okay, so this is pluggable database open, so this is not actually that important. Just an information of the pluggable database information on the CDB. Okay, and next comes the actual main statistics or metric that you need to see, which is elapsed time and DB time. Okay, so here elapsed time means wall clock time. So no matter irrespective of whatever time zone you are in, so you just see your watch. So whatever time that you are seeing, that is the wall clock time. So database will also collect the wall clock time outside the database, and also DB time is the internal time of the database, which means how much work has been done by the database in terms of time. Okay, so here wall clock time is 36 minutes. So how you will calculate this? Just subtract the snapshots. This is the end snapshot, this is the beginning snapshot. Just subtract 1230 minus 1154. So what is the interval between, what is the time duration between these two time? So it's almost 36 minutes, right? If you just subtract 1230 minus 1154, in between there is 36 minutes duration. So that's the time which is printed here. Okay, so this is the wall clock time. So 1154 means in Indian Standard Time it is 1154, and during the end time it was 1230. So that time interval is calculated here. And then what is the database time? So database time will not be with respect to the human time. So this is internal database time, which is calculated based on the amount of work that is done per time. So how you can understand this? So you can take a bank example. So whenever I want to give you any example, I can take the bank example. So here there are 2 banks. Okay, one bank is having 1 counter, another bank is having 4 counters. Okay, so here there are 10 customers. Okay, here also there are 10 customers, or we can take totally 16 customers here. Okay, so let me change the example. here there are 8 customers, say for example, here also there are 8 customers. Okay, so here all these 8 customers needs to be serially waiting in queue. Okay, so imagine that this counter is taking 2 minutes for serving each and every customers. Okay, so 1 2 3 4 5 6 7 8. So if you see here, there is a serialization. So every customers for serving each and every customers 2 minutes will be taken. Okay, but every customers needs to wait concurrently. So after one customer, next customer needs to go. Then after the second customer, third customer needs to go. So here there is a serialization, which means vertically, if you just sum up all these total number of minutes, there are almost 16. You can take 16 minutes for 8 customers. But here you can take the same example. So 8 customers. So here in each counter, 2 customers can be served. Okay. So for each customers, if 2 minutes are taken, here also the same 16 minutes time will take. But here there is a horizontal time. Here there is a vertical time. Horizontal time means here parallelly 4 customers can get served. The time is shared by each and every counters. 2 minutes, 2 minutes, 2 minutes, 2 minutes. So this will not look like 16 minutes. Even though the total time taken for one row. So if two customers are served, then first row will be 1 1 1 1. So first 8 minutes will be saved. These 8 minutes will be further reduced to 2 minutes because 4 different people are working at the same time. Again the next row 1 1 1 1, 8 minutes. Again 2 minutes it will take. So if you see, instead of taking 16 minutes, this job can be done in 4 minutes parallelly. But the actual time taken, actual time was shared by different workers, the counters. That's the reason the time is reduced by 12 minutes. So only 4 minutes are taken. So similarly, you can take the same example here. 82 minutes are there. Okay, so similar to how the 16 minutes of actual work is reduced to 4 minutes. So here parallel workers will be working. So that's the reason, even though the wall clock time is only 36 minutes, how come 82 minutes, how come the database can consume 82 minutes here? So it does not make any sense. So likewise people may ask. So this is also one of the interview question. Okay, so why DB time is higher than the elapsed time? Okay, so before that you need to know what is DB time and elapsed time. So DB time is the actual time taken by the database to process something, to work on something which consumes CPU, and elapsed time is the actual wall clock time. And why DB time is higher than elapsed time? Because of the parallel. So similar to how 8 minutes are reduced to 2 minutes, but 4 different parallel counters are there. So similarly here, just imagine, so if instead of one person, 4 different persons are serving. So here all the work can be shared, but the work will be done parallelly. Okay, so actual work should have been reduced. Actual work would have been done in very less time. Okay, but you need to calculate the actual time taken for each and every parallel workers, right? Similar to how you calculated here. So here, even though it took only 4 minutes totally for serving 8 customers, but each person taken 2 minutes. Here only one person is taking 2 minutes for each and every individual, but here 4 different persons are sharing it. But still we need to calculate, sum up all the time taken between each and every counter. So likewise, if you calculate all the parallel workers time, then you will get more than the elapsed time, the wall clock time. Okay, so that's why the DB time is higher here. So imagine here 8 parallel workers 8 parallel servers were working on something. Okay. So here, if each parallel server consumed 10 minutes to do the work, then you can just see. If you just multiply 8 into 10, it will take 80 minutes, right? But all the parallel servers were working parallelly, so the work would have been completed in 10 minutes. But if you multiply the time taken by each parallel server, it will become 80 minutes. So similarly, this DB time would have been calculated here. So if I'm just giving you some example, but here this 82 minutes may have been shared by multiple sessions. Okay, it may be 8 parallel, or it may be some other number of parallel servers, but this is how Oracle will calculate the DB time here. Okay, so now this is also an indication saying that the workload was high during the time of the AWR report. How you will calculate? Because always whenever the elapsed time is higher than the DB time, then that means the work was less. But if the elapsed time is higher than, if the DB time is higher than the elapsed time, then the work was high. So here the work that happened earlier was high, right? Because the DB time is higher. Okay, so here this elapsed time, this 36 minutes of time will tell us that how much CPU has been consumed. Okay, so if elapsed time is higher than the DB time, then the database does not have any activity. The database did not do any activity. Okay, so next comes the report summary. So this is top ADDM findings. So you don't need to see as of now for this particular section. So next comes the load profile. Okay, so before you go into the AWR report, you need to understand whether the system that where you have collected the AWR report is an OLAP or OLTP. Okay, so OLAP means analytical processing, which is data warehousing systems, and OLTP means transactional processing. So in transactional processing, like banking sectors, all rates will be high. So OLAP systems like sales analytics, the historical analysis of data, right? E-commerce analytics, how many customers were churned, how many customers were getting discount, how many customers are loyal. So these kind of data will be collected, right? So those kind of data are collected during the OLAP, in the OLAP database. And all the online transaction processing. You are doing some banking transaction, you are transferring some money, you are doing ATM withdrawal. So these are online transaction. These requires a lot of writes, DML transaction. Okay, so you may not be, you might not be knowing, or no one would have told this. So before you go inside the AWR report, you need to know this, like how you are verifying whether it is a rack or non-rack system, right? Then you need to further do your analysis. Okay, so here there will be a lot of select queries in OLAP systems. Okay, large selects, large reads. Here small transactions with lot of commits and rollbacks. Here lot of work areas will be used. Work area means sorting. You can take PGA memory will be used. Here lot of SGA will be used. Here a lot of short transactions. Okay, but more number of parses, more number of logical reads in OLTP systems. In OLAP systems, more number of physical reads will be there, less parses. Okay, so this is just an indication, and I'm just giving you a hint. Okay, this does not mean that wherever you are seeing large reads, it will be an OLAP. You should not confirm it, but almost 80 to 90% of the systems with large reads would be also parallel. You will be seeing a lot of parallels in OLAP systems. Okay, you will be seeing a lot of direct path operations in OLAP systems. You will be seeing a lot of checkpoints. In checkpoint is common for every systems. Okay, that also depends. So if lot of batch inserts run, then lot of checkpoints may happen. Also, it depends on the settings. So even in OLTP, you may see a lot of checkpoints, but these are the indicators, okay, to understand whether it is an OLAP or OLTP system. Okay, but still you need to verify it, whether it is a transactional system or data warehousing system. Okay. So this is what the things that I explained here. So you need to understand with these information whether it is an OLAP or OLTP. Right, so just see the logical reads. So here there are a lot of logical reads. So this means that a lot of DMLs should have happened. Okay, and also if you see, physical reads are also high. Okay, so this is where there may be some systems which will be a combination of both OLAP and OLTP. Okay, so they keep 70% OLAP or 70% OLTP and 30% as OLAP reporting, or they may keep 30% as OLTP and 70% as OLAP. So some of the Exadata systems are designed for both of the both type of databases. Okay, so here we cannot directly confirm, but if you see the block changes, and I need to mention this as well. So during an OLAP, if you are seeing a OLAP system, then number of block changes will be less because the number of modifications will be less. But when you see OLTP systems, block changes will be high. Okay, so here we are seeing a few block changes. Okay, we also see physical reads and also logical reads. So here we cannot directly confirm anything. And if you see the read IO requests, lot of reads are happening compared to writes. Okay, so also the read IO is also high. And if you see the SQL work area, okay, even SQL work area is also used. Okay, so this is just a test system, okay, where we cannot confirm anything because I have executed a hybrid transaction model, like both OLTP and OLAP, like both large reads, small reads, and also inserts. Okay, so that's the reason it is a combination of both. So SQL work area, if SQL work area is high, then this means that it should be an OLAP. Okay, and also if number of user calls are high, then this means OLTP. If number of parsers are high, then this also means it is OLTP. Because in OLAP systems there will be few sessions, okay, few sessions consuming large, executing large jobs, long running transactions. But in OLTP systems, many sessions running small jobs. The queries will be short running, which means it will execute within seconds or within less time. It will not execute for hours. Okay, and if you see the number of rollbacks, so here there are no rollbacks, but in generally in production systems, if it is an OLTP, there will be a lot of rollbacks that will be happening, and executes are also high. This means a lot of DML transactions executed. Okay, so this load profile is just for your understanding, okay, whether it is an OLAP system or OLTP system, but still every DBA may be having a different style of interpreting these information. Okay, but I am focusing specifically on the type of systems like OLAP or OLTP. Okay, and it also you also need to check these sections based on the issue. Okay, every time you should not go and check all these things, because this may be a distraction for you, right? So if logical reads are 13,538 per second, you cannot just generally say that this is high or low, right? This may or may not be high, or may or may not be low. if you have something to compare, right? So if you need some baseline reports. Without any baseline reports to compare, you cannot just blindly say that this is high or low. Okay, so next comes the instance efficient percentages. So this is also quite ratio based, proportional. So buffer no weights, buffer hit percent, library cache hit percent. Most of the time these will be 100 or it should be greater than 90. Okay, if something is less, something is 50%, say for example, then that means you need to focus on that area, right? So if library cache hit percentage is 50%, say for example, then that means there is some issue with the library cache. The parsing is not properly done in the shared pool, in the library cache, right? There may be a lot of hard parses. Okay, there may be a lot of unnecessary parses, or there may be parses and those parsed SQL may not get executed. Simply they are just parsing and the application is not executing anything. So even execute to parse percentage. So this is also one of the main metric that you need to see. So execute to parse is the one which will determine whether the SQLs are executed or not. Right? So parsing is completely different and execution is different. Parsing means you are just parsing in the shared pool, in the library cache. Right? So you are doing syntax check, semantic check, and all the shared pool check and all this information, like generating the execution plan, generating the hash value, generating the SQL ID, all these things. But executing means you are actually scanning the data, reading the data blocks from the either from the buffer cache as a logical read or physical read from the disk. Sometimes what some SQLs may do, so some PL SQLs, they will just parse. Okay, parse on the database, which means they will simply parse without any outcome. So there should be some outcome, right? So if you are simply just parsing and you are not executing anything, then that's a waste of resource. Okay, so always this percentage should be high, but here it is very low because there may be some issue. Okay, so executions are either failed or it might not happen. It may not be happening because of some reason. Okay, so this is kind of, you are going for a job. Okay, so you are working very hard, but you are not getting any salary. Then what is the point of working hard over there, right? You need some outcome. So similar to that, parsing without execution is it's a waste of time. And also parse CPU to parse elapsed. So this section also tells you how much CPU has been used for parsing. Okay, so this will tell you whether the amount of CPU used for parsing is efficient or not. Okay, so if you see a less value here, then that means your database is not efficiently using CPU for parsing. It is using for something else other than parsing. So in a database, you should remember that always CPU is not only used for parsing, it is also used for other things as well, like latch, using the latch for NQs and other stuffs as well. Okay, so this means that the CPU is not efficiently used for the parsing purpose. Even you can confirm it from non-parse CPU. Okay, so if non-parse CPU is also high, then that means the database is utilizing CPU onto something else as well, not only for parsing. And others are high, that's fine. And if you next is the most important section that everyone will see. So the top 5 foreground weight events or top 10 foreground weight events. So here you need to first check the percentage of DB time. Okay, so what is the DB time? Here DB time is 82 minutes. Okay, out of those 82 minutes, almost 45% of those 82 minutes is spent on resource manager CPU quantum. Okay, so next you need to check the total wait time and also the average wait. Okay, so if the total wait time is also high, then that means there is some issue. If total wait time is very less, then you can just ignore it. The issue may be at something else. Okay, so sometimes what happen is the DB time will be very less. Okay, say for example, if DB time is only 5%. Okay, so out of that 5%, if 90% of the event is resource manager CPU quantum, then that is there is no issue with that, because the DB time itself is 5%. Only 5% of the database is active. Then there is no point, even though you get 90% here out of 5%, there is nothing, right? So out of 82%, if you get 90%, that is different. Out of 5%, if you get 90%, that is different. Okay, but here there is some issue, because 82% is a high workload, and still out of 82%, 40 to 45% is high. Okay, and also the total wait time is also almost 2000 seconds, and average wait is 13 milliseconds. So these information may vary for each and every wait events. Okay, so for latch you may need to interpret in different way, for IOs you need to interpret in different ways, and for library cache or parsing related information you need to interpret them in different ways. Especially for IO you need to check the average wait. Okay, but still these are just an indication. Okay, so you just check the percentage of DB time. So you don't need to solve all the wait events. That is also another thing. Okay, first focus on only the top few events. I would say top 3 events. Okay, so here top 3 events are resource manager CPU quantum, PX, DQ, and DB CPU. So all these are interrelated. Okay, always you may think that these wait events are something different. It is categorized into different classes, but all these are interrelated. Because of one wait event, another wait event may occur. Right? And always remember that wherever you see PX, parallel means obviously CPU will be very high. CPU utilization will be very high. Obviously, when you see high parallel, you may see direct path read, because direct path read is PGA, or you can say direct path read always uses parallel processing. So definitely when there is a direct path read, you may see parallel. Okay, so now we will focus on resource manager CPU quantum, which is the top event, right? So next is the class. Okay, so this class is just a profiling. Okay, it is just profiling us into a neat output, just for our understanding. And next comes the host CPU. So you can also see what is the CPU utilization and the IO from the host. So if you see percentage user, this is very important. Percentage user means the Oracle utilized CPU. Percentage system means the operating system utilized CPU. So obviously here Oracle database used more CPU compared to operating system. And wait IO, if wait IO is high, then that means there is some IO device issue. So there may be some storage array slowness. Okay, and percentage of idle is also quite 50%. So this means CPU utilization was very high. Okay, and busy CPU. So these are just informational. Okay, and IO profile. So these are also just informational. So you don't need to waste your time on these things. So this is similar to the load profile. Okay, unless until you are specifically troubleshooting some deeper level, you don't need all this information. And memory statistics. So these are just informational. Okay, these are the capacity of the memory, SGA, PGA. So here if you see begin and end. Okay, during the beginning and end, the SGA used for same. But if you see for PGA, it has reduced. Okay, and cache sizes. So these are also informational. Shared pool statistics. So this is also specifically related to parsing. So this section will help you understand whether the parsing is efficiently happening, or there is a lot of hard parse or not. Okay, next comes the time model statistics. So this is also kind of a profiling. Okay, so what was the actual issue type? you can understand from this. So most of the time you may get SQL execute elapsed time, because every database there will be a SQL. So then DB CPU. So DB CPU obviously it should be high. Okay, if DB CPU is not utilized, then your database is wasting CPU, right? It is not it is not underutilizing the CPU. Database should use CPU, but it should not be significant. That is the thing, right? So anything that you have in excess is good for nothing, right? So you can have any food, you can have ice cream, but if you have 10 kg 15 kg of ice cream, then that is bad, right? So obviously similar to that, DB CPU utilization is good, but anything that is excess will hang the CPU. Next comes the parse. Okay, even parse is also only 1.69, so there is no issue with the parsing. Okay, so by seeing the wait event itself, we can understand directly, right? So this is something related to CPU issue, and also the parallel wait. This resource manager plus the parallel, there is some high CPU utilization. Okay, so next comes the operating system statistics. So this is it just gives you a lot of information, but I will explain in some other session about these things. Next is the operating system statistics. Okay, between the start and the end snapshot. So here start snapshot is not collected properly, but end snapshot is having the same which was there previously on the instance CPU. So yeah, so these are just repetitions. Okay, so you don't need to again check each and every section and waste your time. Time model statistics, then the class weight classes by total time. Okay, these are just repeating again and again in different forms. That's it. But if you need some clue or hint, you may need to go through all the sections. Okay, if you are not fully confident with the issue type. Okay, again, if you see, the foreground wait events is repeating. Previously it printed only top 10 foreground events, but now it is again printing all the wait events. So again you are getting the same information. So we already know that resource manager and PX are the issue, and background wait events. Even background wait events is also similar to the same resource manager and PX. So next comes the wait event histogram. So this histogram will be useful in some cases, not all the time. Okay, so we already know that resource manager CPU quantum is the wait event which consume high CPU. So also other one is the parallel, right? So just go directly to parallel and see. You need to check the buckets. Okay, so how many waits happened in greater than or equal to 512 microseconds, and for each and every time limit, or for each and every duration, there is a separate column. This is if you know histograms will be bucketing all the each and every category. So here likewise Oracle has categorized 8 microsecond in one column, 16 microsecond in another column, less than 32 microsecond in another column, till greater than or equal to 512 microsecond. So comparatively, if you just see which weight having more, for each and every buckets, which weight is having the buckets, right? So here if you see direct path read and direct path sync, so here each and every buckets are filled. Okay, and also if you see DB file scattered read and DB file sequential read, all these buckets are full. And if you see for parallel as well, all these buckets are full. Okay, so mainly if the weight is greater than or equal to 512 microseconds, then that is also an issue. Okay, but here you cannot completely say that what is issue or what is not the issue unless until you specifically narrow down the issue. Okay, here even if you see all the parallel events are having each and every buckets having some value. So again wait event histogram up to 64 milliseconds, microseconds. Okay, so this is further down. So here it is to 512 microseconds. Here it is till 64 microseconds, and then 32 microsecond, then 2 second. So it goes on. Further, it is just filtering out. Okay, the specific issue events. Okay, so directly if you see the parallel is survived. Parallel has survived. That we already know by seeing the resource manager event. So here also if you see resource manager also survived, right? So 32 millisecond means most of the wait events will be filtered out because every wait event will not consume more than 32 millisecond. So 2 second is very high. So this is in ascending order, okay, not the descending order. So here 512 microsecond is the starting point, and the largest is the 2 second. So in the 2 second, lot of wait events would be eliminated. Only the specific weights which are having more impact, right? You can what you can do is directly you can go and check the 2 second section if you are pretty confident about it. Okay, so here if you see 32 less than 32 milliseconds 94, and less than half second is 0.3 for resource manager, and even parallel also survived. Okay, you can also see other events as well, which is a repercussion or which is a ripple effect, okay, of other events. Next it comes to 2 minute. This is the only event which survived compared to others. So cursor pin X, S wait on X. Okay, so some cursor has pinned this is some wait mode. Okay, S wait on X means this is some wait mode. Okay, so the cursor is pinned by some session, that's it, to be simple. So that we need to further analyze, but this wait event is not top in the top 5 or top 10 foreground events. So you need to focus only on the top foreground events, not the histograms. Okay, that's the reason when you see each and every section, this may mislead your analysis. You may go into some other direction. Okay, so just take this as an information and just ignore it for as of now. Okay,